All right. So in this next lesson, we're going to kind of continue on with the last one, where we're going to be working with the sine and cosine ratios. But instead of finding angles, we're going to find lengths. All right? So yeah, this is going to be very similar to the second lesson when we used the tangent ratio to find lengths. It's pretty much the same kind of procedure. So let's just get into that first example here. All right. So determine the length of PQ, the nearest tenth of a centimeter. Okay, so PQ, P to Q is this length here, so I'm just going to label it X. All right, so again, the first step we're going to do here is we're going to label our sides. All right, so across from 90 degrees is my hypotenuse. Across from the angle that we're working with is my opposite side. And I'm actually not going to label the adjacent side because it's blank. So yeah, so let's take a look at SOHCAHTOA and choose the correct ratio. So I want the ratio with opposite and hypotenuse, which is the first one. So to set up this equation, write down sine, and the angle we're working with is 67 degrees. This is going to equal my opposite side, which is x, over the hypotenuse, which is 10.4. Right. All right, so yeah, so again, sine is opposite over hypotenuse, so x over 10.4. This is the equation we're going to solve. All right, so just like what we did with the tangent ratio, what we want to do here is we want to consider this sine of 67 degrees. We just want to consider it as a number. Okay, so it's a number that we get by punching into our calculator. So if I want to solve for x, in other words, I want to isolate x. But what I want to do here is I want to multiply both sides by 10.4. The reason for that is so that this will cancel off with this side. And therefore, x is going to equal 10.4 times the sine of 67 degrees. Right? So this we should be able to punch actually in our calculator at once, which I'm going to show you how to do. So yeah, so I'm going to take 10.4, multiply it with sine 67, 10.4 times. All right, so sine of 67. For this calculator, I have to punch in the angle first. The 67 and the sine of 67 degrees is 0.92. All right, so to get this value, I have to equals. And as it turns out, it's going to be 9.573, rounded to the nearest tenth of a centimeter, so 9.6 centimeters would be the answer. All right. Cool. All right, so let's try another one. So determine the length of JK to the nearest tenth of a centimeter. All right, so again, I start off by labeling my sides. So actually, JK is this one right here. That's the length I want to find. So across from the 90 degrees is my hypotenuse. So I'm going to label this as my hypotenuse side. Now, this is the angle that I'm working with, 65 degrees here. So across from it is my opposite side. And again, I'm not going to label this adjacent side because it's blank. So it looks like we're going to use sine again. And I'm just going to write this all out. SOHCAHTOA. All right, so since I'm using sine, because that's the opposite hypotenuse, the way I'm going to set this up is sine of 65 degrees is equal to the opposite over hypotenuse, so 7.6 over x. All right. Now this time to solve for x, what I want to do here is I want to set up a cross multiplication. So sine of 65 degrees, so I'm just going to write that as over 1. Basically what we're going to do here is we're going to cross multiply. All right. So as a result, x times sine of 65 degrees going to equal 1 times 7.6. And now to solve for x, since again we're considering this as just a number, sine of 65 degrees, so I'm going to divide both sides by sine of 65 degrees. These cancel off. Therefore, x is going to equal. All right, and this time I'm going to punch in 7.6 divided by the sine of 65 degrees. All right, so 7.6 divided by the sine of 65, so 65 sine equals. And as a result, it turns out to being 8 point, I will round that to 4. So 8.4 centimeters. All right, is our answer. Cool. All right, guys, so that's it. Yeah. Yeah, so that is finding lengths of sides using sine and cosine. Right. I know both of these examples here use sine, right? But there will be cases where perhaps you're being asked to find the adjacent side, so then you use cosine, or perhaps you're working with an adjacent side and you use cosine. Cool. That's it.